Rotational symmetry. In a plane, a figure has rotational symmetry if there's at least one rotation less than 360 degrees about a fixed point, so that a pre-image, a selection of the figure, maps onto one or more images or other sections of the figure in a predictable way. There are three figures above that display point or rotational symmetry. Can you locate the point of symmetry for each? How would you section each figure to understand the angles of rotation? For this one, we can put our point of symmetry right here, and then if you take this part and rotate it 180 degrees around, you would end up with that right here. So there we go. The next one, point of symmetry right in the middle, and we divvy it up like this. Then if you take a section and rotate it 120 degrees to the right, it would end up here. And if you rotated it 240 degrees, it would end up there. With a star, we can put the point of symmetry right in the middle, and then every time we rotate it 72 degrees, we would end up with the same star, but just turned on its side a little bit. So all of these have rotational symmetry. With rotational symmetry, lines through the center can be drawn in different ways to section the figure into congruent subsections. So this figure can be divided up vertically or horizontally. Here we have the way we divided up in the previous slide. Here it's a little off. However, each section is still congruent to the section next to it. So you can divide it up like this. This star can be divided up into these sections instead of these sections, and so on. Do the following figures display rotational symmetry? If yes, what are the angles of rotation? List all angles in one revolution, 0 to 360 degrees, that apply. So here, we had this on the previous slide. It's a star. We can divide it up into sections like this, the point of symmetry right in the middle, and we can rotate it around. This one, there's no point of rotational symmetry. There's regular symmetry where we can draw a line and fold it over on itself, but there's no rotational symmetry. And here, we can divide it up with the point of symmetry right here, and say we divide it like this, and then we could rotate them as well. So for the list of possible angles, a star would be 72 degrees, or twice that, 144, 216, multiples of 72. B, there's no rotational symmetry, and for this shape, you could rotate it 90 degrees, 180 degrees, and 270 degrees. Do the following regular shapes have rotational symmetry? If yes, what are the degrees of rotation? List all angles that apply. All right, so we put a point right in the center, and we can then divide this triangle up into three congruent parts like this. So you can rotate this part around 120 degrees in order for it to end up right down here. For the square, we put a point right there. We can divide it up into four sections like that. And then if you were to take this one section and rotate it 90 degrees, it would end up right here. All right, here we'll put a point in the center and divide it like that. You can take this one part, rotate it 72 degrees, and it will end up in the next spot over. Here we put it right in the center and divide it like this. If you take one section and rotate it 60 degrees, that is the smallest amount that you could rotate it, where it will end up perfectly in the next section over. All right, for here, bunch of sides, 3, 4. All right, so you could take one of these sections and move it 51.43 degrees, and that would end up in the next section over. And then finally, we have this one. All right, divide it like this. And then if you take a section and rotate it 45 degrees, it will be here. This also works for multiples. So for example, if you move this piece 45 degrees, it will end up here. But if you move it 90 degrees, it will end up here. if you move it further than that, if you just keep going in multiples of 45, you'll keep ending up at the next space over, like that. So all of that, and that works for all of these. So if you were then to move this piece to 40, you would get here. If you were to move this piece here 180, you would end up over there. I used the same color. You would end up over there. So these amounts, 120, 60, and so on, are just the smallest amount you could rotate them to get to the next point. But you could also rotate them in multiples of those numbers. So we have all of the possible multiples of all of the degrees for all of these shapes. And the rule that applies here is that if you want to know what this amount of degrees is, the minimum amount, it's 360 divided by the number of sides the shape has.